right, we're going to go ahead and move on to our next graph called an ogive, which is fun to say, and it is related to the last two graphs we've drawn, histograms and frequency polygons. First, this guy gets another name. He is also called a cumulative relative frequency graph. And you can now see why I like ogive so much. Much easier to say. Cumulative relative frequency graph, on the other hand, does a much better job of telling us what this graph is. So remember that we've talked about frequency before. We know that frequency is a count. I'm counting up how many of my sample subjects are in each category or in each interval. I know relative frequency means percent. I'm looking at the percent relative to the whole. And cumulative in other classes usually means keeping a running total. I'm adding things as I go. So cumulative means to add up the data values as I work my way down the table. When I plot it, what I'm going to be plotting is I'm going to be plotting the class boundaries on the x-axis, versus the cumulative relative frequency on the y. So the hash marks on my x-axis look like the values I was plotting in my histogram. And then this is then going to be a modified value for the y. We're taking what we had before and we're changing it. Instead of bars, we are going to make a dot for each of those class boundary cumulative relative frequency pairs. And then, just like the frequency polygon, we're going to play connect the dots at the end of this process. All right, so what I'm going to do is I'm going to do two things. First, I know cumulative relative frequency means relative frequency first. I need to take my counts and turn them into a percent. So I'm going to do that in the original table. So I know there's 50 people in my sample. I interviewed 50 men, collected their shoe size. So I'm going to take each of those numbers, I'm going to divide by 50, and I'm going to leave it as a decimal. So 0.08, 0.28, 0.40, 0.22, 0.00, and 0.02. When I plot this, my pairs are going to start with the lowest class boundary, which is, sorry, I don't know why there was a lag there, 0.895, and then the cumulative relative frequency that goes with it. And I need to think about my data set. We were looking at men's shoe sizes, and the smallest value was 9, the biggest was 14. If my smallest value is 9, I don't have any data that is less than 8.95. So the cumulative relative frequency, the sum of all the frequencies up to that value, is 0. And then I start working my way. 9.95, I should have 4 people that are less than 9.95 in shoe size, and I know that's a relative frequency, a percentage of 8%. As I go, I am going to add. So for this next row, I'm going to add those two because I don't have 14 people less than 10.95. I have 14 plus 4 that is less than 10.95. So that's 0.28 plus 0.08, which is 0.36. And then I keep going. I'm going to add this guy. I'm going to add this guy. I'm going to bring over the new and add it to the old. So for 11.95, I've got 0.36 plus 0.4, which is 0.76. For 12.95, I have 0.76 plus 0.22, which is 0.96. For 13.95, I add the 0.0, so 0.96. And then for 14.95, I add the 0.02, and that should take me to... Did I miscount somewhere? I did, and there's nobody here to catch me. That should be 1, but Mr. Jolliffe doesn't know how to add. 6 plus 2 is 8, 0.98. 0.98 plus 0.02 is 1. I did that correctly. So in a cumulative relative frequency graph, or ogive, that first CRF should always be 0. That last CRF should always be 1. So these graphs are always going to start at 0 and end at 1. That's how we know we did them correctly. From here, I'm going to set up my axes. I need 1, 2, 3, 4, 5, 6, 7 hash marks on the x-axis. So 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go out one more just in case. And then on the vertical axis, I need to go from 0 to 1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. So uniform number scale and then axis labels. And our y-axis is cumulative relative frequency. And then on the x-axis, our lowest class boundary is 8.95. And then all the way up to 14.95. And then we plot our ordered pairs. I'll go ahead and do that in green. So at 8.95, we should have 0. And then 0.08 is going to be a little bit less than 0.1. 0.95, we're at 3.6, so right about here. And then we jump up to 7.6, which is up here. And then we jump up to 9.8, 9.8, and 1.0. And then my last step, I play connect the dots. So first to second, second to third, so on, all the way across. And I forgot to label my x-axis. Shame on me. And that is an ogive. You will notice when we did histograms and frequency polygons, we got very similar shapes. They were effectively plotting the same thing. With cumulative relative frequencies, or ogives, we're plotting a running total. It's always going to grow and grow until it hits 1. So we are most often going to see shapes that kind of look like S's. And where that big jump occurs tells me where my peak is in the data. So I know my biggest peak is here in this region where I've got 14 and 20. So between 9.95 and 11.95. And if I look at my graph, that's where I have that biggest jump, that steepest slope. All right. If you have any questions about ogives, feel free to send me an email. Otherwise, I will see you in our next video.